Welcome back to this tutorial, and this is the second project on our data science project driven sessions. And in this tutorial we are going to look at a different type of data, that is crime data, and we're going to do some analysis. But unlike the previous project where we were answering a business question, in this project I'm specifically focusing on some of the challenges that you will face as somebody who is modeling some data or analyzing some data. So without much further ado, let me pull up the data that we are going to use for this session. So this is a data set collected for the year 2021 about crime, arrest made in the Washington DC area, and this data is available. I will send a link for anyone who wants to download the data by year. So there's a data available for 2020, 2021 and 2019, so you can do that comparison. But a brief background of the data is we have got different columns. I've sorted out the columns that I think are necessary for this project. We have got the year, which is obviously 2021 in this case. This is for the whole year. And then we have got the date that somebody was arrested. And then we have got the hour of arrest, 0 meaning midnight. And then the age distribution of the age of the person who was arrested. And the race, it can be either black, white, or unknown, Asian, and multiple. So that is the classification for race. And then we have got the ethnicity, which is basically the distribution in terms of different races, whether it's Hispanic or not Hispanic. And then we have got the sex, grouped into two, either male or female. And then the arrest category, which basically is the type of crime in broad sense based on the police classification of the crime. And then we have got the latitude and longitude. So these are the locations, or the geospatial locations, of where the crimes were committed. So what I want us to focus on this data is look at some of the common problems that comes up whenever you are analyzing a data. And the reason why I pulled up this specific data is to give you that sense of what you experience in a real data set, not the artificial data set that we normally get in our programming classes. So as is the custom, let's start with the basic libraries. So let's import the necessary. So I'm just documenting for your use. Libraries to help in this analysis. So the libraries that we need, we're gonna need, I think, import numpy as np. So we're gonna use NumPy in some of the cases, and then we're gonna use pandas, which is very at the core of data science, speedy. Then we're gonna use matplotlib. Let me just copy this from internet. I don't want to type the whole. This is for plotting, and of course we're gonna use Seaborn, which is also a library in, or a module within, matplotlib. So these are the libraries that you're gonna use. The next thing is to import the data. So as I said, the data is available on our, you should have it on the description, but you can also download it straight from the website that I'm going to provide. The data is called the crime data. I've already provided it or shown you. Have it on your primary folder where you are working, so that you don't have got issues with the location. So it's a CSV file, so we're going to use, and we're going to create a data frame, give it a name or a variable. So the name of the data frame is going to be df, to mean data frame. And then since this is a CSV, we use the pandas, which we have imported the library pandas, and use the function read CSV. And then we input the name of the dataset that you are reading. So the name is this, so we just basically copy this and have it inside our parentheses to read that data. And then confirm that the data has been read by displaying the first 5 rows. And you can see this is our data. So all the columns have been nicely imported. We can check the size of this data by using shape. you can see it's 15,653 data points. So there was a lot of arrest in DC in 2021. I think this was during COVID-19 or post COVID-19. We can equally check at the columns to see the kind of columns that we have, although you can easily tell that you have got 10 columns, but it's just good to display their name so that when you want to copy them, we copy them directly. As you know, the first thing that you do for a data is to check for any missing values. So let us for any missing values. So we use the isNull function of pandas to check for that. So first of all, we call the name of our data frame, which was df, and then use the isNull function to check for any missing values. So it should return true or false. So true if there's a missing values, false if there's no missing values. But it's hard to read the whole data frame because some of this has been compressed. So normally the way I do it is to read each of the columns by creating a list that contains each of the columns. So let me create a list called features, which is basically all these features of the data set. And to do that, I'll just copy each of them from the above script that the above code that I used. And then I will now write a function to check, let me run this, to check if any of these columns have got missing values. So to do that, I will iterate through my list for feature. So for every column inside this column called, so every column inside this list called features, I'm gonna check if there's a value missing. So for feature in, if you are not sure about how to write loops, please check my previous tutorial on that. And then let me assign a variable or a holder that is gonna hold the null values. So it's called null check. And I'm gonna use the function in pandas. Pandas also got a function that allows you to check if there's missing values in your data frame. And that function is called isNull, as we used previously. And then here we input the name of the column. So the name of the column or the column of the data frame in this case is each of these data frames, each of these columns here, which have been assigned the variable called feature. So we're gonna use that, and then I'm gonna print to see if there's any that has got missing values. Then print null check. So if I run that, you can see it's false for the indexes. The first one is the indexes, the next one is the arrest year, false, multiple false. We have got arrest date false, which means it doesn't have got any missing values. Same goes with the arrest hour, age, defendant race, ethnicity, defendant sex, arrest category, latitude. So most of them are returning false, just to show you that okay, some are not returning all the values. But let me return the whole data frame by adding here df to truly check if each of the data frame or each of the data points are having any kind of missing value. So when I do that, you quickly realize that the column latitude and offense longitude have got a lot of missing values, and therefore the next thing that we need to do is to find a way on how to handle that. So if you have got missing values in your data set, there are always three ways of doing it. You can use the average value for that data set or that column, or you can use the mean, the mode. So sometimes, let's say that in this your data set, you have got missing values under the defendant race is male. So you can, you have got, okay, so you have a missing value in the column defendant sex, and you don't want to lose it. You can add the mode for that missing value. So if let's say column 2 was missing any value, you just check that what is the common defendant sex in this data frame. If it's the male, then you use male to add that. That can be tricky for some kind of data set. So in most cases, you might want just to drop it. If it's a numerical data, like maybe temperature data, you can use the average to do that. Or in worst case, you just drop the whole column. And that is what I'm going to do for this case. So I'm going to drop that using the pandas function called drop NA. So if you check, before we drop any column, we have got 15,653 data points. But when I do df.drop NA, then it's going to reduce because you have dropped we have dropped some data points. So let me do shape. That's going to reduce to 16,632. So from 653. So in other words, we have lost around 21 data points that didn't have got values in columns, the longitude and latitude columns. So the next thing is, I want us to group and see how the crime is distributed along different features. So this is the kind of the textbook analysis you do to see or come up with the analysis on the crime patterns in DC area. So I want us to understand how the crime or the arrests are distributed in terms of age, in terms of race, in terms of ethnicity, and in terms of category. So this crime or arrest pattern. So these are arrests. So to do that, I'm going to use the group by function of pandas to help me with grouping this arrest. So the first one I want to group is age, because our date and year are all numerical values and they are having a lot of resolution. The resolution is very, very fine, such that if I start grouping them, I will have got lots of data points that might not make sense. So those kind of data set is always good to use other distribution functions like histograms to group them to understand the key metrics or how it's distributed among the people. So we're going to do that also. So let's start with the more less refined data points or less refined features, that is defendant race, ethnicity, and sex, and also category. So I can do that, and starting with, so this is going to be age. So I'm going to just group all of them in one cell so that we don't have got lots of unnecessary cells. So let me use categorical. So I'm classifying the features that are more categorical and not those that are numerical. So the first categorical feature that I'm going to use is the defendant race, because you realize, and we can always check the options here simply by looking at the name of the column that you are interested in and check all the possible outcomes of that column using the pandas function unique. So I can do df, and I'm interested in the defendant race to see the unique values for that column. So I'm going to do that and then make it unique to see the options that are available there. And you can see it's either black, white, unknown, Asian, multiple, or others. So these are the race categories in this data frame. So first of all, I can also do that for other columns by just changing the name of the column here, and it will give me what other options exist in terms of, for example, ethnicity, or for purpose of exploration, let me use arrest category. So you can see all these are categories of arrest that exist in this data frame. So it means under the arrest category column, this is what you expect to see in each of the data points. As you can see, they are very, very categorical. It's either this or that. But if you look at something that is like an age or an arrest hour, then it is more of their immediate categories. Somebody might be arrested at 1, 2, 3, 4, 5 until the next 24 hours. Or the date can be as high resolution as possible from the first month or the first date of the year to the last date of the year. So you don't want to use this kind of group by function to do that. You want to use something that is more useful, like the histogram. So in that sense, let's try to group this data set in terms of the race and see which race or which ethnicity has got the maximum number of arrests. And then again, it's important to have a rider here that by using that, we are just using that for purely for exploration of data and not trying to profile any particular race in terms of arrest or driving some narrative that is not necessarily true. We are just using that for purpose of classifying or categorizing this data. So we can do that by using the group by function, and we create. So first of all, let's just use group by function and then assign it to a new data frame. So first of all, use the name of the data frame and then use the group by function from pandas. And then inside here, we input, or instead of using or going the direction of using races, I think that might drive unnecessary information. So let me use the arrest distribution by sex, so that we can either tell whether the number of maximum arrest was from male or female. That's sex, and then we use the size, we group them by size, and then we want to reset the index so that we don't have issues with our missing index. And let's try to name the column that is going to store the number by classification as numbers. And then we can run this. Once we run this, you can see that in terms of the arrest, only 3,419 females were arrested. 12,000 males were arrested, and then unknown. This is people who we don't know whether they are male or female were arrested, only 6 of them. So this is the distribution of arrest by the sex. So this is what you can do, and then you can assign this to a new data frame, maybe for visualization. df, let me call it df sex. And then now we can plot it using Seaborn or Matplotlib. So I'm gonna use plt figure to create a figure size. So fig size equal to 8 by 5. plt.x label. I'm gonna do the x label is simply going to be the defendant race, defendant sex. So for easy clarification, let me just display the data frame here so that you can see why I'm doing this. So essentially, we are going to plot numbers against the defendant race. So in other words, we want a bar graph that will tell us the numbers or visualize these numbers in terms of the sex of the defendant. So the X label is going to be the defendant sex, which is this one's either male, female, or unknown. And then the PLT or the label, the Y label is simply going to be the total numbers, which is given here. And then the X is the actual plots. So it's gonna be the name of our new column is df.sex is df underscore x, and then the x values we are simply plotting these ones. So I'm gonna copy the name of the column, and then the y, still I'm using the same data frame, Control C, and I'm using the column numbers, and then I'm plotting it as a bar. So I'm gonna do plt dot bar x comma y, and then lastly, I think this can work, so you can make it nice. So you can see this one is more detailed, or it gives you clear visualization rather than using the raw numbers. It's better you visualize it as this so that it becomes easier. We can make it beautiful by adding grids to this our plot, plt dot grid, and I showed you this in the previous section. So I want them to be on the both axes, x and y, and then the line style, I want them to be dotted, so I'm gonna use the full colon. So if I do that, you see we have got grids on our plot. Lastly, I can save this figure using the save fig function that allows me to save the plots directly. So I can say defendant, which is the name of the plot, x, but I want it into JPG, and of course I can define the resolution. So I'm gonna use, let me use 480, it's so highly resolute. So when you run this code now, it's gonna save this plot into your folder where you can use it for reference, or maybe something like a presentation. So let me pull up. You can see here is our plot, nicely plotted. So it's lacking something, it's lacking a title. So I can do that by adding here plt dot title, then saying arrest by 6. Now our plot has got a title. So now you can do this for the other remaining features. That is, you can do it for ethnicity, for RS category, and then for the race. So please, as a takeaway assignment or an extra work, please could you repeat the same for classifying them or group them by those features, and then make different plots and post them on the comment section so that I can be sure that at least somebody somewhere is watching this video. Otherwise, I have no way to tell whether you guys are really watching and following what I'm doing. So please do that. But that is not the whole idea of this video. The major part of it was to handle how you deal with this continuous data set. So that in this case, we were just using categorical data set, which is fairly easy to deal with. It's either female, male, unknown, or it's all this. But now let's try to replicate the same thing when we are using continuous data like the age, because you realize that the age of the person arrested can extend from 18 to as high as maybe 90, depending on whether they're still old and want to fancy or run around committing crime. So that is something that I wanted us to learn on how we can handle that. So as you realize in our previous session, we said that the easiest way to do that, and we can take an example of this. First of all, let's start. Let me create a column here, or a heading. Continuous. Specification. So we want to do the same thing, but this time round, we are not doing it for a data that is well categorical like the sex of the defendant, but we're going to do it for something like age, which is continually distributed. Because if you look at age, we have 38, 31, 35, 31, 21. It can go as high as 90. So let's do that first of all. So we just group them, but this time now, let me change this to age and see what comes up by using the group by function. And I'm gonna change that to age. And let's classify it. So this is the classification. You can see we have got already 69 rows, which means there are 69 types of age. So you can't literally plot this on a bar plot, or you can try do it and it will not be nice looking. Let's try it. Can just copy the whole of this, reuse the code, but where we have race, we just simply change it into age. So defendant, this is gonna be arrest by age. Numbers remain the same. This one is gonna be age, and of course this is gonna be df.age. And I don't think if we need to save this plot because it's gonna be terrible looking plot. Let's run it. You can see how this plot comes up. It kind of looks like a histogram, but it's very hard to interpret. It's very hard to interpret because we have got very thin bars. You can see there are age ranges where more people are committing crime, like 20 years, around 20 years, and also around, this should be around 30, and then also around 40s, and then around 55. So reason for that, that's where subject matter experts comes in. And I want you to also take keen interest on the data point here, where we have got 120, and this is actually one of the reasons why I decided to make this tutorial, so that you know how you handle this, because you realize that most people that are committing crime are within this age range, but there's like 2 or 3 people who are committing crime at this 120. So the best way to handle this kind of data set that is not categorical and more of continuous is to use histograms. And histograms can be easily used in Python using the seaborn function by just calling the displot, and that will give you. So we have got a function called displot in seaborn that takes in the column name of the data frame that you want to use to show the distribution. So in this case, we are interested in the age column. So I'm just gonna do that, and then we have, you add the option KDE, which is basically the kernel density function that allows you to do that. And then beans is the groups, the number of groups you want to group your age range. So let's use 8 for this tutorial and see how it's distributed. So you can see again, we have got this weird looking graph, but generally it's positively skewed with the tail towards the positive. So this is very common in your data. So normally we expect this kind of data set to be normally distributed, but normal distributions only exist in theory. In real data set, you find that maybe a certain, like in this case, the highest number of people committing crime is within the age of 20 and 30. And the least number of people committing crime is within 120 and 80. And I said this 120 is the whole reason why we are doing this video. So as you can see, the best way normally to know how to handle this data is to look at how the distribution is. And when I talk about distribution, first of all, you need to know what's the maximum age, what's the minimum age when you are grouping this data. So to know the maximum and minimum age, I can say create, or I can simply do df and select the age column, which is like that. And then to know the minimum, I just use the function min from pandas, And then I can also do the same for maximum, same syntax, except that instead of min, you use maximum. And this will allow me to have both the values so that I know the age range. Then print, but I don't need to print this. Let me run. I think it should allow me to do that. Okay. So it only prints the last one. I can do, can send this a variable df min. You can send this df max, and then I can do print df min, comma df max, so that I can have the min and the maximum. So the minimum age of the person who committed crime or who was arrested from this DC dataset was 18 years old, and then the oldest person who was arrested who have committed crime in 2021 is 121 years old. So the reason why I ask you, this doesn't look right, although we know that people get aged until maybe 120 years old, but it doesn't look right. If you can see the distribution, probably I'm assuming that maybe an error was made on this dataset, or even if it's not an error, if we are doing analysis with this dataset and we retained this value of 120, it can easily skew our data and make it inaccurate, especially when we subject this, our dataset, into, or we are modeling this dataset. It can skew our data, and therefore it's normally important that we remove those kind of errors. And the best way to check if there's this kind of data that is not is very distant from each other. So you realize that in this case 120 is very, very different from the rest. You see, like, most values are falling between 120 and let's say 70, and with some only 80. So these values that fall away from each other, that are quite distant from each other, are normally called outliers in data. So outliers are very, very tricky. They might show you something, or they might be the point of discoveries, but in most cases, if you are modeling, then you don't want to use them because they can easily skew your data. So in statistical terms, we normally say outlier is an observation that is numerically distant from the rest of the data. So like 120 is very, very numerically distant from 80, compared to 60 from 80, or 40 from 60, or 20 from 40. So you don't want to have those kind of data sets because of the same reasons I've told you. So the way to normally detect anomalies, and this is what I wanted to show you in the whole video, is, so let me write detecting anomalies. Should be a heading. So the easiest way to detect anomalies in your dataset is to use boxplots or whiskers. So it's the same name. So boxplots or whiskers are very, very important, are useful in determining whether a dataset is anomalous or is an outlier. It means it's very, very distant, or statistically or numerically distant from the rest of the data. And Seaborn allows you to do that easily using one line of code. So I'm going to use SNS as Seaborn, and then just call the function called boxplot. And then inside this function, you simply input the column name, or the data and the column name, the data frame and the column name. So we are interested in the age, and this is going to return the box plot for this. So if you look at the box plot, you can see that we have got 3 lines, and this is where it gets interesting. And I want us to look at this very keenly. So this is the box plot, and box plots are showing us something unique. So now, how do we correct for these outliers, or how do we remove these outliers in your data set? So that is the whole idea behind this tutorial, and that is a very, very useful skill because you're going to use it a lot when you're analyzing and modeling your data. So you want to remove outliers. So let me just write that. Detect and remove. So I've already written first. So to detect, so we have already detected the outlier using the box plot. The next thing is we want to work our way around on how we can remove that outlier so that our data can make more sense. So first of all, we calculate the upper and the lower limits. So here we are simply calculating the upper edge and the lower edge limits of our this current data that you are handling. So to do that, let's use the Q1 to mean the quartile range 1. Let me say Q1. That will be our first quartile range. So I'm gonna do df, which is the column. So the minimum is the 25th percentile. So that's 25% of the data. So 25% of the data is simply 25 divided by 100. So let's use the column name, which is edge. And then Python has got a good function called quantile, which allows you to calculate the quartile. So I'm going to use 0.25, which is the lower, or 25%. So 0.25, because 25 divided by 100% will give you 0.25. And then I'm going to use the upper limit is going to be the 75th quartile, because we have divided our data into 4 quartiles, 1, 2, 3, and 4. So the third one is 75. The last one is 100. So we don't care about the 100. I will just copy this. But as we said, it's 75, so 25 becomes 75. So now what each of this represent is Q1 represent the first line here, or the first edge in this range, and then Q3 represent this other one, or the last part of the box, and then the distance, as I said, between Q1 and Q2 or Q3 is the interquartile range. So to do that, I'm gonna use, to calculate the interquartile range is simply the subtraction of the two, so the highest minus the lowest. So interquartile range, IQR, is going to be this Q3 here minus Q1 and once we do that, I can calculate QR. I can return QR, so it's 16. So that is the interquartile range. In other words, the difference between the highest or the lowest edge and the upper edge for this number of, or the age of the arrested individuals. So to calculate the lower one in terms of what we are looking for, you can say lower is equal to this Q1, and you realize that if you subtract the last one from the first one, we're gonna have 1.5, which we multiply by the interquartile range that we have already calculated here. So that will give us the lower value, and we can do the same for the upper value, but now we are simply subtracting. So instead of subtracting, now we are adding, and that will give us the upper value. And now let's run that. The next thing, now we want to ensure that any value that is within the range, this range here, so if it's if the value is below lower, that is, if the value is below, is falling on this region here, then we're gonna assign it a 0 value. And if it's up, or it's above this upper value, anything above this region here, then we're gonna assign it also a 0 value, so that now we come up with an array that contains either 1 or 0 as a way. So let me just illustrate that. Create boolean to show outliers. This I think is markdown. So we can say upper array. So we're gonna use numpy dot. So anywhere we can use the function where if df age or the value of age. So this where act as the same as the where in SQL for those guys who are into SQL. If this one is greater than or equal to the upper value, which is our upper value, then you assign it a boolean of 0, and I will repeat the same now for the lower case, except that now lower is gonna be if it's less than or equal to the lower value. So this one is gonna be lower, and instead of upper here we use lower. Okay, so now we have gotten our array. The next thing now is to actually remove those outliers. So eliminate outliers. So to eliminate them now is very easy. We're just gonna drop any values that I've got are either on the upper array or on the lower array. So we just do df and use the drop function in pandas and check the index. We drop the index where upper, where we have got upper, and then reset our index to be true. We copy the whole of this, do the same now for the lower array. So I'm getting an error. The best thing to do in this case, sometimes we do have cases where running your code multiple times brings up this issue. So let me just run it from the top. Okay, so it's not finding a bunch of access. The problem must be on how. Okay, so I see where the problem is. So when we are defining the upper, we use the lower quartile to do that, which should have been the third quartile or the 75th percentile. So let's run this and then rerun our code now. It should work. I'm having this new set of problem. Okay, so let's run everything now. Yes, so you can see after removing the outliers, now we have 15,401 data points. So we have removed all those outliers that could have easily skewed our data and give us a wrong kind of model if you are to use this for subsequent lessons like, or subsequent advanced practices like trying to predict where the next crime is going to happen. So the whole idea for this tutorial, before you do that, please kindly try to focus on one of the columns or two. Specifically, I will advise you to focus on the arrest hour column and see if there's any anomalies in the arrest hour. If there's none, usually you don't have to find the anomalies, but just check on your data. Take one of the columns with the numerical values, that is the arrest hour, and then try to detect any anomaly on that column, or you can even use the date arrest column and try to detect an anomaly and try to correct it using the same approach that we have done. And please post on the comment section if you have detected an anomaly. I would have given you a hint, but I don't want to do that. Please do it on your and submit your answer on the comment section, and then we can have a discussion over there. We have come to the last part of this tutorial, and I think the whole idea was to show you how you handle problems that exist in your real dataset that you will obtain outside there, not the toy or the model dataset that you'll get from libraries or from online classes. So subsequently, we're gonna do a lot of in-depth analytics of crime, and we will focus on pattern analysis and do point pattern analysis for the crime, and we can also do some visualizations. I think I will show you how to do those visualization in very simple approaches like on Google Maps. And I think maybe if you're still out of time, the data set that you have, you can actually display it because it has got latitudes and longitudes. So you have got a latitude and longitude, so you can plot this on a Google Maps. And the easiest way to do that is to use there's a very good tool. If you are working on Google, you have got Google account, just type my maps, like in my case, my maps, and then go to this here, click my maps. It will give you a way to create a map. So click on create a new map, and then add layer, or not layer, sorry, delete this layer. So go to let's start from the beginning. So my maps, create a map, and then you go to import section where you are importing your data. So my data is, click on the browser, and then it's the CSV file, open, and then it's gonna ask you select the columns which have got, or will tell you where the location is. So for you to plot the location, you need X and Y. So the X in this case is the longitude values, and the Y is the latitude values. So I'm gonna use the offense latitude, and that will represent the latitude, and then longitude to represent the longitude, and then continue. And then you pick the column to use as the title. So if these arrays have got a unique identifier, then you can use that. But in my case, maybe I will use the date, then finish. So it's gonna plot that data because I told you it's from DC. It's gonna plot it within DC. So you can see it has plotted it here, and you can select the base map to see the background. So I'm gonna use that one so that it stands out. And then you can do the uniform style. So the uniform style will basically classify the data by the attribute you want. So I want to classify them by, let me use just sex, because that is like 3 options, and that's it. So I can remove male, change the place mark here to a different color. Let me use red. I think red will fit the bill. Use a smaller icon like dots. Okay. And then I'll go back to female. I'll use green. Then use the same dots. Okay. And here you are. So now we have got our data nicely displayed. To show the distribution, and indeed the map is the map of DC. So you can do this, but now in the next sessions we're gonna do a point pattern analysis. Once you get into that comfort zone where you can easily manipulate the longitude and latitudes, it's gonna come in the later sections of the tutorial. I'm not going to promise it now because we have to learn those softwares that will allow you to plot this data, and that is a whole package of it. So stay tuned for spatial analysis of this crime analytics. And with this now you can easily tell the distribution, which areas are having more crime rates on the things like central median, central mean of the crime. So that is just a gist on what is coming up next. Please, if you have not subscribed to the channel, do so. Tell a friend to tell a friend, like the video, share. Until next time, bye bye.